the laws of thermodynamics and some consequences and uses that these laws are put to. The first law states that the internal energy of a system increases as heat goes into it. Just kind of a duh statement, I guess. Oops. And decreases, I can't write, goodness, as work is done by it. And internal energy is called U. So in the equation form, what this says is that delta U equals Q minus W. And as I said, it increases as heat goes into it. So a positive Q means that heat is going into the system. And since it's minus W, if we plug in a positive work, that means that work is done by the system. U, internal energy, is a state function. Which is in some ways equivalent to what we learned about conservative forces. It's a state function, meaning that only the starting and ending points matter. So if you know the state of a system at one point, you know the state of a system at another point, then you know the change in internal energy between them. But you don't know how much of that was heat going in or work being done or vice versa. Yeah. So, I mean, it's not a matter of where it is in space, but the concept is the same as, if you move an object through space, going from here to here. As far as the state function is concerned, this is the same as, this. Path 1 is the same as path 2. And that's the case for internal energy. Going from state A to state B, it doesn't matter which path you take, the change in internal energy is the same. What is different is how much heat goes in, how much work is done. So for example, if your delta U is some negative number, well, there are different ways that could occur. You could be hanging out outside in the cold so that heat is leaving your body, or you could exercise and do work on stuff in that way, and your state function would be changing, energy would be decreasing in that way. So there are multiple different ways you could reach the same point in the state function. Just a quick little example, say as I am teaching, I give off 2.6 times 10 to the 4th joules of heat, and I do 9.7 times 10 to the 3rd joules of work. What is my change in internal energy? And this is it's a simple problem. This is just a subtraction problem. Delta U equals Q minus W. But I want to clarify the SIGN signs. So delta U, a positive Q is heat going into the system. So if I'm giving off 2.6 times 10 to the 4th joules of heat, that's a minus 2.6 times 10 to the 4th for Q because that heat is leaving the system, that is me. And then I do 9.7 times 10 to the 3rd joules of work. Well, work done by the system is positive, but it's a minus in the equation, so that's then also minus 9.7 times 10 to the 3rd. And so then we can figure out how much my internal energy changes. Let's see, what are these line up? The 2 and the 7. So that's minus 0.00996 joules is the change in my, times 10 to the 4th. Whoops. Sorry. 712, there we go. So the 6 and the, so that's minus, let's see, 007, 6 plus 9 is 5, 3. So minus 35,700 joules is the change in my internal energy. Generally speaking, for most things you do, you will be losing internal energy, which you then regain by doing things like eating. And you get that energy back from your food, generally speaking. The second law of thermodynamics is very simple and kind of obvious, and it's something I think actually I've already told you, but I didn't say it was the second law. The second law says essentially energy flows spontaneously, meaning if you just leave it alone, it'll do it on its own, from high to low temperature. Again, this is kind of duh when objects are in thermal contact. Energy flows from hot to cold. That's kind of a duh thing, but that's why it's a fundamental law, and this, flow of energy, spontaneous flow of energy, is very useful in terms of machines that do work, particularly heat engines, which we will explore in the next video segment.